10th Physical Science, Lesson Chemical Bond, Topic Valence Cell Electron Pair Repulsion Theory, V.S.E.P.R.T. So, means valence cell electron pair repulsion theory. Bond length or bond distance. Equilibrium distance between two nuclei of two atoms is called bond length. It is measured in nanometer or angstrom unit. For example, here A, B, two kinds of atoms comes together. When we measure the distance between the two nucleus of atoms, so this distance is called bond length or bond distance. Next one, bond energy or bond dissociation. It means energy need for breaking two atoms in covalent bond is called bond energy. For example, here we can see the two types of atoms, A and B. So here between these two A-B atoms sharing the electrons between two A-B atoms. So covalent bond is formed between the A and B atoms. When we supply some energy to break this covalent bond, so then it is called bond dissociation or bond energy. Drawbacks of electronic theory of valency. Hydrogen bond and fluorine bond is seen here. So in hydrogen bond, the bond length is 0.74 and bond energy is 436 kilojoule moles minus 1. And in fluorine bond length is 1.44 and bond energy is 159 kilojoule moles per 1. When we observe these two covalent bonds, bond energies and bond lengths are different in covalent bond. Boron trifluoride, we can see 120 degrees angle, and methane 109 degrees 28. So it cannot explain the angles of bonds and shapes of the molecules. So BF3 and CH4 covalent bonds. So this electron theory of valency cannot explain the angle of compound and shape of the molecules in the compound. Valence cell electron pair repulsion theory. So this theory explains about the bond angles between atoms attached to central atom through covalent bond is called valence cell electron pair repulsion theory. So the electronic theory of valency cannot explain about the angles between the elements and the shape of the molecules in the compound, but valence cell electron pair repulsion theory only explained about the bond angles and also the shape of the molecules formed in the compound. For example, here we can see the central atom C is there. Around the central atom C, we can see the different atoms A, B, C, D. So another atom surrounded around the C central atoms. Next one, lone pairs and bond pairs. So what is called lone pairs and what is called bond pairs? Electrons not involved in bond formation is called lone pairs, and electrons involved in bond formation is called bond pairs. For example, here we can see the hydrogen compound. So in hydrogen compound, what elements are there? Hydrogen, oxygen. Formula is H2O. 2 hydrogen atoms are there and 1 oxygen atom is there. Around the oxygen, we can see the Lewis structure of electrons. So valence electrons are there around the oxygen. So here between the oxygen and hydrogen, we can see the shared electrons. The oxygen and hydrogen share the electrons present between the oxygen and hydrogen. 2 hydrogens are share the electrons from the oxygen. Next, another electrons are there, but they are appearing lonely. They are not involved in bond formation. So these electrons are called lone pair electrons. So these lone pair electrons not involved in bond formation. And between the oxygen and hydrogen, the electrons present between oxygen and hydrogen, they involved in bond formation. So they are called bond pairs. So lone pair electrons are there and bond pair electrons are there. So here some more examples are there about the bond formation by using some bond pair electrons. And lone pair electrons are also there, but here the lone pairs and bond pair electrons, when getting repulsion, so then the angles are formed between the elements. So how can they angles are formed between the elements? So let us see. First example, beryllium chloride. So here beryllium is there and 2 chlorine atoms are there. 1 atom beryllium and 2 atoms chlorine is there. In the beryllium, valency electrons are 2 is there, and 1 chlorine atom 7 valency electrons are there, and another chlorine atom 7 valency electrons are there. So these 2 chlorine atoms gain the 2 electrons from the beryllium. So by overlapping on the beryllium and chlorine and getting the electrons from the beryllium, then the covalent bond is formed between the beryllium and chlorine. So the central atom is there, beryllium, and the chlorine atoms are stay on both sides of the beryllium. So here we can see the sharing the electrons between the beryllium and chlorine, and another chlorine also form the covalent bond with the beryllium by sharing the 2 electrons. So here we observe the only bond pair electrons are there. Why? Because the beryllium sharing the electrons with the 2 chlorines. Okay, here we can see the repulsion between the bond pairs. So the angle 180 degrees are formed between the beryllium and chlorine here. So other atoms are chlorine and the central atom is beryllium. So here we can see the angle 180 degrees and shape is linear shape. Angle is 180 degrees and linear shape is can be seen in the beryllium chloride covalent bond. So it is very important. It comes as a blanks in the examinations. Beryllium chloride shows the angle 180 degrees and the shape linear shape. Why? Because bond pair is formed between the beryllium chlorine, and bond pair when shows repulsion, then the 180 degrees angle formed in this beryllium chloride and getting the shape linear shape. Okay. Valency electrons of beryllium overlapping with valency electrons of 2 chlorine atoms, so 2 covalent bond formed around beryllium and chlorine without lone pairs electrons. Bond pair electrons get repulsion and stay on both sides of the beryllium, getting shape linear and the angle 180 degrees. So here we cannot see the lone pair electrons in the covalent bond of beryllium chloride. On both sides of the beryllium, the chlorine atoms are stay and sharing the electrons with the beryllium. Next, getting the repulsion of bond pair, 180 degrees angles are formed and linear shape also formed in the beryllium chloride covalent bond. Next one, B.F.3. So here we can see boron. Boron has a 3 valency electrons and fluorine. So fluorine has a 7 valency electrons. So how many fluorines are there in this compound? 3 fluorine atoms are there. 1, 2, 3. Okay. So boron has a 3 valence electrons. So fluorine atoms 3. So boron lost 3, sharing these 3 electrons with 3 atoms of fluorine. Here we can see 3 bond pair electrons involved in 3 covalent bond around the central atom, separated by 120 degrees and getting trigonal planar shape. Here we can see the central atom boron and surrounded by fluorine atoms. So here covalent bond formed between the boron and fluorines. So what pair of electrons are there here? Only bond pair electrons are there. Between B and fluorine, valence electrons are there. So these are bond pairs. Next, other fluorine and boron bond pairs are there. Here also boron and fluorine bond pairs are there. So here we cannot see the lone pairs. Lone pairs cannot seen in these B.F.3. So here bond pairs are 3. So these bond pairs getting repulsion. So 120 degrees angles are formed in the BF3 compound and getting the shape trigonal planar shape. So it appears trigonal planar shape. Okay. Next example, methane. So carbon has a 4 valence electrons and only one carbon atom is there, and carbon is a central atom and other atoms are 4 hydrogens are there around the carbon. So here we can see 4 valence electrons carbon shared with the 4 hydrogen atoms. Between carbon and one hydrogen, 2 bond pair electrons are there. Second hydrogen carbon shared 2 electrons, so bond pair is there. Third hydrogen with carbon shared the bond pair electrons. Fourth hydrogen carbon shared the bond pair electrons. So here also we cannot see the lone electrons. So 4 bond pairs form the tetrahedron shape. Tetrahedron shape. And between these two elements we can see the 109 to 28 angle and tetrahedron shape. So 4 electron pairs around carbon shows 109 to 8 angle and tetrahedron shape. So here we can see the methane. 1 carbon, 4 hydrogen atoms are there. They form the covalent bond, and when these 4 bond pairs getting the repulsion, then forming the angle 109 degrees to 8 and shape is tetrahedron shape. Next example, ammonia. Formula NH3. Nitrogen 1 atom is there, hydrogen 3 atom is there. Central atom is nitrogen. Around this central atom, other atoms are 3 hydrogen atoms. 3 bond pairs, 1 lone pair is there in ammonia, and lone pair occupies more space around nucleus. 3 bonds comes closer. Lone pair bond pair repulsion is greater than bond pair repulsion. It has 107 degrees 48 and shape is trigonal pyramid. So here central atom nitrogen and other atoms 3 hydrogens are there. But here bond pairs can be seen and lone pairs also can be seen here. Lone pairs. So these 2 electrons not involved with another element. But here we can see the bond pair between the nitrogen and hydrogens. And here 2 types of repulsion can be seen here. The repulsion between the lone pair and bond pair, and the repulsion between the bond pair. Okay. So the repulsion between lone pair and bond pair is greater than the bond pair. So all these hydrogens comes below side and these bond pairs comes together. Here we can see there is a more space around the lone pair. Next here when we see the bond pair, there is a the bond pairs comes together. Okay, so the repulsion between the bond pair is less than lone pair bond pair. Okay, so then because repulsion, these compound getting the angle 108.48 and the shape is trigonal pyramid. Next example, water. Water formula H2O. Two lone pairs and two bond pairs of electrons present around the central atom. Lone pair and lone pair bond pair repulsion get 104 degrees 31 angle and get V shape. So here is the covalent bond formed between the hydrogen and oxygen. So here we can see the two lone pairs. Above the oxygen we can see the two lone pairs and below we can see the bond pairs. Oxygen sharing the electrons with the one oxygen and another oxygen also sharing with the electrons with the hydrogens. So two lone pairs are there and two bond pairs also there, and above the oxygen we can see the two pairs of lone pairs, and below the oxygen we can see the two bond pairs. And here two types of repulsion can be seen here. Lone pair, the repulsion between the lone pair and the repulsion between the lone pair and bond pairs. So by this repulsion between the lone pair and lone pair and bond pair, so these compound getting the angle 104 degrees 31 and shape V shape. V shape means bending shape. Lone pairs are throws the bond pairs below side. So the water we can see the V shape. Okay, so all these about the valence shell electron pair repulsion theory. So lone pairs and bond pairs are there. When these lone pairs and bond pairs getting the repulsion between them, forming the angles between the elements and also getting the shape.